Oh, thank you very much, and thank you very much for inviting me. And obviously, I'm very keen to talk about my favorite topic, which is, mathematical development. And as Susan already mentioned, it's part of a series of 3. So today, the idea is just to talk you through mathematical development from birth to primary school. I may mention things that you already know, but it's just to refresh yourselves so that the session tomorrow and especially next week will hopefully make some more sense to you as well. So it's going to be a little bit interactive, and I might ask you to put things in the chat. I can't really see what's in the chat, but I'm sure I can ask Susan then for some input. We'll also do a little exercise where I'll just ask you to speak out loud, but obviously we don't need to hear you. You can just do the exercise for yourself as where you are. So in today's session, I'll start talking a little bit around what do we mean by mathematical development, because, that might mean different things for different people, depending on what ages you work with of children. We talk more about what factors influence mathematical development, and obviously I'll use evidence from current research for that, and then talk a little bit at the end around how important are these early mathematical abilities that I'll be discussing for outcomes later on in that.
Adam.
Okay.
Sorry, Jo, could you please mute your microphones, please?
Are we good to go? All right. So first of all, I want to talk a little bit around what do we mean by mathematical abilities. And I'm going to use a cognitive definition rather than maybe an educational definition. And what I mean by that is that when I refer to mathematical abilities, I refer to the ability to obtain and process and retain any kind of mathematical information. But we also can think of it more as a pragmatic definition, where we look at the ability to perform mathematical tasks and effectively solve mathematical problems. And the two I probably will be using a little bit interchangeably. So we're talking about all the things that children need to know, need to do in order to process, in order to perform or solve mathematical problems. So the first thing I think that's important to know or to focus on is that when we talk about mathematical ability, it's a range of abilities. We're not just talking about one different thing. And actually, this is a quote I took, so it's around using formal language, operating within formal structures of connection. It's the ability to generalize and to think in logic sequential manner. I think what makes mathematical ability really special is the fact that you can learn a set of rules, but what is difficult about those set of rules is that you need to abstract it to whatever context or situation that you're in. So for example, when we teach a child to take 2 and to add 3, that 2 might be in one case the number 2 or the digit 2. In another case, it might be 2 cars. In another case, it might be 2 spoons full of sugar. And so basically, there's a high level of abstraction that is required when we talk about mathematical ability, and that abstraction or that logical sequential manner of generalizing is required for solving any problems. And I think that's what makes mathematical abilities really difficult for young children to learn. So we talked a little bit already around what is mathematical abilities. I would like you to put in a chat just a word around when it comes to mathematics or this kind of more cognitive thinking around mathematics. What do young children you think have to know or learn? And so when I say young children, I think around children up to the age of primary school. So I'll give you a minute. Does anyone want to put in? So what do you think young children need to learn when we think about mathematics? Anyone wants to put anything in the chat? Vocabulary, thank you very much. Yes. Number spaces, correspondence, yes. Counting skills. Anything else? Bonds, number bonds, yes, absolutely. This one-to-one correspondence is very important too. Oh, estimation, thank you for those. Yeah, principles of counting, categorizing, problem solving. I'm sure we can keep going. So there's lots of things that children need to learn there. the difference between ordinal and cardinal is another very good one. So when I make a list and think of what young children need to learn, we can count around things like this. So counting has been mentioned. And obviously we start off by reciting the number of words, and I've got another slide later on around counting in more detail. People might also have mentioned, reading and writing of symbols. Someone else mentioned number magnitudes, knowing which one is larger, and that helps us to estimate very quickly where it's a larger number or how much we need. We also have meaning of operator and symbols. What's a plus, what's a minus, what's a multiplication. That leads us to number facts, knowing what is timetables, what's 4 times 4, what is that? Not only around, what's the answer to that, but how do you solve that? What's the meaning of that? As well as numerical procedures like borrowing, carrying, and then maybe towards the end of this primary school, we learn about principles. Someone mentioned also some counting principles and the law of mathematics. So we're going to focus more on these few things here around counting and number magnitudes and number facts, etc. And then think around how early and when do children come to understand this, and what are kind of like the cognitive developmental processes behind it. So this is an overview, kind of like what the mathematical abilities are of children in terms of arithmetic abilities.
This ends at 5, but I can order the dinner
and as you can
anytime
see,
and have it delivered,
very early,
or you can pick it up.
Almost at the age of when children are only 4 months old. Children can already add and subtract one. And way before children actually start to use any language. And
okay,
so basically,
I'll order it at
mathematical
4:30
development
if
starts
you want to give me the
infancy.
list.
And what we know from early studies already in the 1980s is that, for example, 10 and 12-month-old infants can crawl to a box that has some crackers in it. So if you take a box, a jar, a see-through jar, and you put 2 crackers in or 2 biscuits in one, and maybe 3 or 4
Alison Linnick
in the other joining, you would put it 1.5 meters, 2 meters away from an infant, and you just put the infant down and see what would happen. The infant will probably crawl to the jar that has the most biscuits in it. We also know that, as I mentioned before, 4 to 5 month old infants can add and subtract 1. So this was a study done by Karen Wynn, and what she done in the US is she showed a screen, and she showed the child that, on this platform, one Mickey Mouse doll was added. Then the screen went up. Whilst the screen was up, another doll was added. And then the infant saw 2 possibilities. Either the infant was then shown that when the screen came down, there were 2 dolls. Now, obviously, that's the right answer, right? Because if we have 1 and we add another one, you have 2. Or the infant was shown only 1 doll on the screen. And what happened is that these infants who were part of this experiment, when they saw only 1 doll being on the screen, when this occultation came down, they looked longer at this 1 doll compared to when they saw 2 dolls, showing that infants were kind of surprised when the answer wasn't what was the correct answer. And this has been replicated a number of times, showing that even young infants have some kind of understanding of what this adding or subtraction might mean. And so this has led people to an understanding that infants have a kind of object tracking system. We call it Core System 1 for mathematical abilities, that allows infants to keep track of small numerosities. And it allows precise representation of distinct entities. So basically, the way to think about it is like in your memory, you would have a filing system. And every time you see an object, you would open a file in your memory. So if the infant sees 2 dots on a screen, for example, in their mind, they would open 2 files, one for this dot that corresponds with that one on screen, and another one that corresponds with the other dot on the screen. Now, when the infant is then shown, for example, 3 dots, the infant would go like, well, I've got one in my mind for one of the dots. I've got one in my mind for the other of the dots, but I don't have one for a 3rd dot. So this is odd. It's an unexpected answer. And so this object tracking system therefore works on a one-to-one correspondence between the information that the infant has in mind and the information that the infant is shown on a screen. And And of course, because infants and even adults, we have a limited capacity in terms of how much information we can keep in our mind, there is an upper limit to how many objects infants can keep track of. And we know that is often 3, limited to 3 items. Now, this ability that infants have of keeping track of different objects and kind of being able to compare 2 items versus 3 items, or doing this, adding and subtraction of 1, is a precursor for a process that is called subitizing, and you may be familiar with this. So in order to show you what subitizing is, I've got an activity for you. I'm going to show you some dots on the screen, and I know no one can hear you, but just for fun, shout out loud how many dots you can see, okay? And it's going to be quite quickly. So I hope you're all ready, because here we go. So shout out how many dots you see on the screen.
3. Too many.
Too many. There you go. So as you hopefully have experienced, is that this was very easy when there were only a few dots on the screen. So if I go back, this should have been easy. Most people were able to say 3. Most people would have been able to see 2. This would have been harder. Some people might have said 6, for example, and this is impossible without counting, or even this one, in order to be precise, right? And so this is what is called subitizing. So subitizing is the ability to estimate precisely how many items there are without the need to count. So what you see is that, there you go. So that's knowing the numerosity of a visual array of objects at a glance without counting. Whereas counting is more complex, and we need to keep track of the number of items using this one-to-one correspondence and really counting all of them in order to understand how many there are, or the Cardinality Principle. Sorry, let's change it to Cardinal. It should be Cardinality Principle, of course. And so this is something that Brian Butterworth has assessed quite a long time, replicated, but it was done the first time in the 1990s. So basically what he did was he showed number of dots on a screen to undergraduate students and participants, and he measured how long it took them to count or to tell him the exact amount that was shown on the screen. And as you can see here, so here on the y-axis, this is time, and on the x-axis, you've got the number of dots that was presented on the screen. And as you can see, is that there's not much difference in the amount of time it took people to say whether there were 1, 2, 3, or 4 items. But when there were more items, you can see there was kind of like a consistent increase, a linear increase between the number of items presented and the number of time it took participants to give the correct answer. And so what this shows very nicely is that when there's only a few items, 3 to 4, people don't have to count, they can subitize. So at a glance, without counting, tell how many items there are. Whereas if it's above 4, people had to count, and you can see that increase in terms of time it took. So this ability that infants have to kind of keep track of objects relates to this kind of ability of subitizing, knowing how many there are at a glance. But obviously, and this subitizing ability is a precursor for later on counting, so when children need to keep track. And I'm sure you're familiar with this, but I just wanted to quickly go over the development of counting. So as you may know, counting is a complex skill. It's more than just one thing. And it takes therefore a place across development between the ages of 2 to 6 years old. So children start off the development of counting with learning the number names, and that's what we call the stable order principle. They first have to learn that the number words come in a stable order, right? It's always 1, 2, 3, 4, 5. And you may know this because when you ask young children to count, they will always go 1, 2, 3, 4, 5. And if you say, well, count again, what's next? They will go 1, 2, 3, 4, 5. And their counting will always start with 1 and then almost like a nursery
practicing with the knife.
Recite the numbers. Only a little bit later, children will start to understand that when you're counting, you should actually count each item that is presented. And we do this by one-to-one principle. So, and pointing, therefore, might be a helpful tool to keep track of which item is already counted and which one is not. But at this stage, when children are figuring out this one-to-one principle, or when they've figured this one out but not really understand counting, what you might see is that when they're counting these 3 dots, for example, they'll go 1, 2, 3, 4, 5, 6, 7. So they're using 1 to 1, but they kind of don't understand what counting is for or when to stop counting. So what they don't understand yet is the cardinality principle, which means is that when we're counting, we want to count the numbers that are presented and know how many there are. So kind of the understanding what counting is for. One way of assessing this, if you've got young children or you're working with them, is to give them a bag with toys. It could be marbles, it could be any kind of objects, and to kind of ask them and say, can you give me 4? And see whether they just give you a random number or whether they can actually give you 4 items exactly. And you might want to give this, you know, a few trials just to see that the child isn't just guessing. But basically what you'll see is that children who understand what counting is for will give you the exact number. And children who don't have this cardinality principle yet, they'll just give you a random amount. So we call them grabbers. And then, of course, children also learn that we can count anything in life, right? Almost everything is countable. Even, you know, grains of sugar are countable, even though you might not want to actually go and count them. So the idea is that, you know, we can count everything. So the abstract principle is something they need to learn as well. We can count sounds, we can count actions. And also then later on, children will learn that the order is actually irrelevant, so that you don't always have to start counting from 1, but that you can count onwards, for example. So at the age of around 4, we see that children understand this, and that when you say, well, start counting from 5, they can actually do this and don't have to start from 1. So I hope that gives you a little bit of an understanding around how counting develops and how that's already related to abilities that infants have very early on in life. But we don't always have to count. So again, I've got this little activity for you. I hope you're all ready. This time, I'll be showing you 2 sets of dots on the screen. One set will be red, one set will be blue. And I would like you to shout out the color that has more dots. So it's either going to be blue or red. Okay, so this is not easy again. We'll go fast, but hopefully you're ready. I'll start in 3, 2, 1.
Blue. Blue. Red.
Wow, okay, very good. Thank you for participating. So this is what we call estimation, and it's something, again, that 6-month-old infants have. And what you'll see is that this is sometimes easier and sometimes harder. And this is what we call core system 2 or number sense. You might have heard this already. So this ability, it's a cognitive ability, allows infants and young children and adults to see the difference between larger numbers really fast. It's not really related to counting because it's all about approximate estimation. And we actually use this a lot in our daily life. So think about, you know, when you go to the shop, or a better example was in the past when we were still using actual money rather than, you know, using our bank cards, is when you were getting a taxi and you wanted to go somewhere, you had to kind of roughly know that you had enough cash on you to pay for the taxi ride. And so in order to do that, you'd be using your estimation. You might also have used this if someone asked you to pay for something and you think it's kind of rather expensive. Well, how would you know it's rather expensive? It's because you're using your prior knowledge and your estimation ability. Now, in the task that we've been doing, we've been, you might have found that some estimation was easier compared to others, and that's because the system relies upon Weber's law, which depends on the size of the dots as well as the ratio of the numbers. So basically here, if you've got not so many dots compared to many dots, that is a lot easier than, for example, if you had the next trial, for example, where there's a similar number of dots. Apologies, the timer was on there. So basically this number sense is important for mathematical abilities because it functions as a checking system.
Okay.
So you might have already, you know, and you see this as well with young children, is when you add lots of numbers up and you're using a calculator, when you come to the end of it and you kind of go like, my calculator is wrong. Of course, the calculator isn't wrong. You might have added the numbers in incorrectly, but your number sense or your checking system allows you to kind of monitor whether you've solved the problem correctly or incorrectly. And you can already see, or as we'll be discussing tomorrow, it's this system where children with learning difficulties often have difficulties with this kind of number sense or an understanding how numbers relate to each other. So so far we talked about two core abilities that are part of mathematical development. These core abilities develop early onwards in life. As I say, infants have this ability as well. So infants are able to tell where there are more dots by looking at them for longer, for example. I don't have time to go into that in detail, but maybe at the end, I've got some time left over, I can explain more about this. But basically what we've seen so far is that, mathematics is a multi-componential subject. So it's not just one thing. We already see that there are two core systems there. So you have these mathematics specific skills such as counting, and that also includes later on when children go to school, they use that includes strategy use, conceptual understanding, the math facts that they might learn that they need to access. And we've looked at, these numerical representations, understanding what are numbers and how do they relate to each other, which relates to this number sense or core system. Your estimation ability belongs to that kind of system as well. But solving mathematical abilities or being good at maths actually also includes a lot of other abilities. So for example, we know that the language in which you learn maths matters. So some languages like Japanese and Korean, they have a very what we call transparent language system. Once you've learned as a child the numbers 1 to 10, then it's really easy for you to learn numbers beyond that, because 11 is actually 10 and 1. So here, for example, Ichi is 1 and
Maybe you're
Ju
going to
is
pay
10.
for this when you
So
go,
11
or
is Juichi. So it's very easy for children to kind of learn to count, or also to learn how
only if their
1
machine
and
is
10
down.
and 11, which young children in English find really difficult to understand, is very much easier for children who are learning transparent languages, for example. Apologies. And this is exactly what some research has shown, is that, so this is a study by Anne Dowker at the University of Oxford, who compared children in the UK who were learning mathematical abilities, children in Hong Kong who mainly spoke English, and children in Hong Kong who mainly spoke Chinese. And of course, we know that there are differences in the education system, but by comparing the Hong Kong English to the Hong Kong Chinese groups, she was able to examine the direct effects that language has on mathematical learning. And what you can see here is that although at the beginning of the school system, so first and second graders, there wasn't any difference between those who are studying in Hong Kong or pupils learning in Hong Kong between Chinese and English. But when they were in the third or fourth grade, you can see that there's already a difference appearing. And as you can see, the English children are trailing behind. So this is kind of the difference in education system. And here's the difference in the language system. So the language which you learn maths matters. Apologies for that. There's other domain general abilities that matter as well. So for example, working memory abilities really matter. So we know that working memory is the system that deals with auditory and visual information and allows you to manipulate that information. And of course, that matters in mathematics. For example, if I say 2 and add 3, then children need to keep the number 2 in mind and the number 3 in mind, and then do something with that information, which means adding that information up, for example, and manipulate that. So keeping track of which items have been counted requires working memory ability, keeping track of the numbers, as I already mentioned. And we know that from our own research that I'm involved with, is that working memory measures predict which children are low performing on mathematics above other measures, for example, number sense or processing speed. So working memory abilities really relate to how well children will perform on a mathematical abilities task. Not only working memory, but also executive functioning abilities. And so by this, I mean the ability to inhibit information, also for infants to shift attention from one item to another. And again, if you think around, if you want to add 2 and 3, you need to inhibit all other information that's not relevant. So we're not talking about 6, and you don't have to think about 7, you just have to think about numbers 2 and 3, but also able to shift attention. And this is something that children, for example, with ADHD find really difficult, and therefore that might impact them on their mathematical abilities. Another domain general ability that matters for young children is visuospatial ability. Visuospatial abilities is your ability to orientate yourself into space and to understand how different objects relate to each other into space. And the reason why this matters for mathematical abilities is because numbers relate to each other. And very often when we think about numbers, or if I ask you to think about them, about numbers, you might think around numbers being on a line with, you know, the number, and because we read from left to right, that numbers that are small are probably on the left of your number line, and numbers that are large are on the right of your number line. And I'm sorry, in my animations, this didn't work because this is what I wanted to show you. So when people are, for example, thinking about numbers, they will look at the left top corner when they're thinking about small numbers, and people tend to look in the right corner when they think about large numbers. So if you go like, oh, think about 110, people might look at that right corner. If you say, think about number 5, people might look more towards the left. And we also know, like the snark effect, that if you present numbers on the screen, for example, number 3 and number 8, and you say which one is larger, people can do this faster if the larger number is on the right and the smaller numbers on the left, for people who read from left to right. So if you do this in Arabic countries, for example, this needs to be reversed because they read in a different reading direction. So we know that visuospatial abilities, how things relate to each other, also impacts on mathematical abilities. And then finally, I want to talk about motor development. Is another domain general ability that really impacts on mathematical abilities. So we know from research by Nikki Pitchford, for example, that in 6-year-olds, the way how children were able to do various fine motor tasks, picking up pegs, for example, and how fast they could do this, predicted performance on their mathematical task better than reading tasks and other abilities. And we also know that intervention studies, which I'll be talking more about in session 3, that include whole body movement, improve number line performance. And number line performance is this ability to know how numbers are spaced on a line, such as you can see here. So here in the middle, you can see that the numbers are not evenly spaced. And this is what we see when young children draw on a number line compared to at the top, for example. And so interventions that include whole body movement, such as walking or roaming free or jumping, improve number line performance. And this was researched by Fisher et al. So these are a number of domain general abilities, motor development, language, working memory, inhibition, that all impact on how well a child will be doing in terms of their mathematical development. But it's not only these domain general abilities. We also know that a home learning environment is very important. So if we look, for example, this is a study by Mulhouse et al. In 2008, on what factors have an impact on the mathematical abilities of children age 10. You can see here, like, you know, they measured birth weight, they measured whether it was gender, they also measured the socioeconomic status of parents, which we know matters for almost all learning. Mother's education is a significant one, as well as, you know, the home learning environment in general. So this is around how much do parents focus on mathematical abilities and what kind of informal activities they do with their children. And in our own research, we looked at how often do parents focus on reading and on mathematical abilities. And what you find is that parents focus a lot more in either formal activities like explicit book reading, but also informally talking about letters, pointing out words when you're driving, when you're walking, a lot more than when they're focusing on maths. So, you know, saying to children, well, look, there's, 40 miles per hour, it's a 4 and a 0, for example. So there tends to be a more focus on reading than there tends to be on maths within the home learning environment. And not only in the home learning environment, in our own research, quite a number of years ago now, we've recently published, we looked at what do preschool providers think about mathematics and reading, and how much time do they spend on each of these activities. And so we had 83 providers across a number of preschool settings, both privately and maintained preschool settings. And what we found was that these preschool providers rated literacy abilities more important than numeracy abilities. And this was by the question just saying, you know, how important is it for a child to be able to read by the time they're 5 years old, and how important is it for children to know all the number names, etc. We also found that across these preschool providers, they focused a lot more on literacy activities than on numeracy activities. So this was on average in a week, how often they focused on formal activities or informal activities. And we had a number of examples where they just had to rate this. But we also found, importantly, that the confidence of the providers mattered, and that they showed higher confidence in providing literacy activities than in providing numeracy activities. And I kind of skipped through this last one, but it's about, you know, how much did they enjoy school, how much did they enjoy maths or numeracy and literacy at school, and how important they were. And as you can see, the providers mentioned that they were much more confident in or enjoyed literacy activities a lot more than numeracy activities themselves. And indeed, that's what a number of research studies have shown already, is that affinity towards mathematics and maths anxiety really matter in this whole story as well. And we know that, you know, actually the story told by correlations is sad indeed. The higher the one's maths anxiety, the lower one's maths learning, mastery and motivation. And so this is where I think it's important that we focus around what kind of activities can preschool providers and parents do in the home or in their preschool settings to improve, you know, to grow this affinity for mathematics from a very early age onwards. So we've covered, I mean, this is a kind of a whistle tour stop to all the things that are important for mathematical development, but I hope that I've shown you that mathematics or you know, supporting children's mathematical development really requires a multi-componential focus, because mathematics is a multi-componential subject. So good mathematical abilities don't just require on these mathematical specific cognitive abilities such as knowing the number names and counting, or number sense and understanding how numbers relate to each other, but also depend on a number of general cognitive abilities such as working memory, Visio, Spatial, inhibition and switching, as well as the home environment, as well as obviously the school environment and the teachers within those environments. So how important is it then that we focus on mathematical development within the early years or very early onwards? Well, we know that from longitudinal studies that mathematical abilities early on in life predict educational outcomes as well as financial success. We know in the UK that a number of students see maths as boring or difficult, and therefore, if you look at the mathematical pipeline, that they often drop mathematics quite early onwards compared to other countries. And a number that I've always, you know, I'm a foreigner myself, I'm originally from Belgium, I've always been quite surprised by how we talk about mathematics in general and how many people really have maths anxiety. So we're more likely to say, oh, I'm not good at maths, than to say, oh, I'm not good at reading. And we very often say, oh, we need to split the bill at the end of a lovely meal. And we'd say, let's get the calculator out, or can you do this? But we rarely say, I'm not very good at reading, can you read me the menu, for example? So there's this divide between maths and reading. So in terms of long-term predictors, things to work on or things to start thinking about. So what we know in the early grades, so early onwards, and this is evidence from a longitudinal study by Geary et al., is that these domain general abilities, such as working memory and intelligence overall, or problem-solving abilities, were more important for children's long-term mathematical outcomes than the domain-specific knowledge, which is, numerical operations was a test they used. So this is counting knowledge. But then obviously, as children get older and go through the later grades of primary school, we see that this number-specific or domain-specific knowledge becomes important. So we can talk about this more in session 3 or later on, but it seems like if you want to improve children's early mathematical abilities, it is around getting the whole package ready and to get children's attention, working memory, problem-solving abilities ready so that they can learn all the other mathematical specific knowledge. So that's all I want to say for today, so we can leave some time for questions. But I hope I've shown you that mathematical abilities is actually multi-componential, that it depends on as much on domain general abilities, and especially in the early years, and that these early abilities really matter for long-term outcomes. So thank you very much for listening, and I very much welcome any questions or comments you may have. And I'll stop sharing so I can see.
Thanks, Jo. That really was very, very interesting. I think there's probably a lot of information in there that resonates with a lot of people on the call. So as Jo said, this is a creative conversation. So we do actually leave a bit of time at the end for questions for Jo, and I would open the floor to the audience to see if anyone has any questions at all on any aspect of what Jo was presenting, and please don't be shy. For those that did ask about the other sessions, I will contact you and I will get you a space, so please don't worry about that. And the presentations will be made available as well as the recordings. So Steve, can I bring you into the conversation?
Yeah, I just wanted to make a comment actually. Towards the end there, we were talking about parents' attitude. I work with adult learners, and the amount of people I have coming through who say that they were actually put off counting and learning about numeracy and mathematics by the parents. But tell them, I can't do that, so it's not really very important. So I see that very regularly with people coming through for help with numeracy, that they've been put off going into it and working with it because of their parents' attitude, because they didn't like it. And that sort of supports the message that you were given at the end there about the ability.
That was a wee bit broken up for me, Steve, but I'm thinking you were talking about the intergenerational transfer of well, negative thought process around maths and how that has impacted on the children.
Yeah, that was what I was just saying that's what I found with a lot of my adult learners who come along, that the reason that the reason that they're coming and looking for help now is because they were put off it by parents and bad teachers. Sorry to say that in this company, but way back, I mean, a lot of the ones I'm working with are my age now, so none of you people will have taught them. But your bad teachers in the past have put them off. So that's what I find with a lot of adult learners coming back.
That's a very good point, Stephen. And I think it's around, we need to think around keeping young children motivated around mathematics. And I think we can do this by incorporating maths activities in daily life. And hopefully I can show you in session 3 around how we've done this in our research. And obviously then, it is around keeping that motivation up as children get older and go through their primary and secondary school. And that's around, again, ensuring that children start off, I think, with the right knowledge. So, making sure they have the working memory abilities, that they have the inhibition, the ability to switch. I don't know what it's like. I don't know too much around the educational practices in Scotland, but I do know in England, for example, is that all manipulatives are taken away or are discouraged to be used from when children are in year 2 onwards. And that's very early onwards, where their working memory abilities, we know they develop up until the age of 8, 9, but even 11, 12. And so children who are maybe summer born or who might be a little bit slower in their development, they won't have those working memory abilities yet to actually manipulate the mathematical information in mind. So we might say that they have a mathematical ability problem and they might find mathematical abilities difficult, but it might be because they don't have these domain general abilities yet to support their mathematical development. So I think as an educator or as a parent, being aware of, you know, what are children doing when they're solving these problems or when they're doing this activity? And you know, is it really that they don't know the counting names, or might it be that they need other equipment to support their learning, for example?
Thanks, Jo. We've got a very, very specific question from Carol. Carol, are you there? You're working with and I'm not sure you'll be able to answer this, Jo, but Carol, did you want to ask that question about the twin boys? If you're there. The question itself, Jo, I think Carol's maybe having problems with her sound, is that she's working with a set of twin boys aged 8 who keep missing out the number 13 when counting. Is there a reason? I don't know if you can answer that.
No, but I think it'd be, you know, at the age of 8, most children, unless there's any special needs, which obviously I'm not aware of, but is whether they there's a reason for it, whether they, you know, sometimes twins might have this kind of secret language, etc., that they don't like, and they might have gone.
Alison Linnick.
Oh,
is now exiting.
And it might be because, you know, they don't like a particular number, or is it because they don't know that number? But yeah, it's very precise. I mean, it is common for younger children when they start to learn the number sequence that they skip numbers, and then it might take a while for them to remember. You know, 7 is often one of the culprits, you know, until they're that particular age. So we also see that, you know, once children are that age, they no longer make that mistake anymore. You see this with very young children. So once they turn 3, they know the number 3. Once they turn 4, they know the number 4, etc. These children at the age of 8 are a little bit older, so I'm not quite sure why. It might be that they have a specific reason maybe for it.
Okay, so Karen, Karen Jury? I don't know if you're there, if you want to come in and speak to Jo.
Hi, Jo, can you hear me?
Yes, I can, thank you.
Hi, yeah, I just wanted to ask you a question. Just when you were talking about the working memory ability, it sounds so much like a little 6-year-old boy that I teach. This ability or inability to hold the number in his head, he's 6 and he still finds it very, very difficult to add on one more. And he, even though the rest of the children can count on from 5, he really, really struggles with that. And I was just wondering, is there anything that we can do to help support a child develop their working memory?
Yes, so I mean, there are programs like COGMET, for example, that have argued that it trains working memory. I think the evidence for such programs is actually not very robust in terms of that, you know, there's no long-term effects where it doesn't really transfer to improving mathematical abilities. I think the better way to do it is to look at mathematical tasks and support to working memory abilities within the tasks that you're doing. So, for example, when the child's got problems with onwards, is to provide a number line and always have that number line present so children can keep track. An abacus is also very useful so they can keep on counting. And you know, and there's also nothing wrong with counting onwards with your fingers. I mean, children can subitize up to 10. Obviously, it doesn't work with numbers up over 10 because you don't have more fingers than that. But to kind of use those memory aids to help him to develop it further.
Okay, that sounds great. Thank you.
You're welcome.
And Karen, Steve's just put in the chat that he uses Lego bricks.
Yeah, Lego, again, Lego therapy or anything with Lego has been shown to improve mathematical abilities, not only from a working memory point of view, but also because Lego, putting things together with Lego, builds children with your spatial abilities. And as I mentioned before, that's another aspect of or domain general ability that kind of supports or forms the foundation for good mathematical abilities. So Lego is a good thing. The other thing you might be surprised to hear is actually online video games is a good thing to support children's mathematical abilities. And again, especially these games that require children to orient themselves in kind of like a virtual reality or a virtual environment, because again, that allows children to think more abstractly and also to develop a visio-spatial awareness and abilities.
That's all been really very helpful. I'm sure he'll love the Lego. Thank you. Thanks.
Thanks, Karen. I don't know if I've missed any questions, Beverly or Vince, in the chat. But if anyone else has any, yeah.
Just scrolling back through to see if I've missed any as well. But for anybody it's talking about session 2 or 3, I've taken a note of your name, and I'll check out and see what's happening. So we will be back in contact with you about that. And as you know, the session is being recorded, so you'll get a copy of the presentation slides, and you'll be able to view the session again on our Education Scotland YouTube channel for future. So don't worry about that.
We've got a question from Colleen in the chat around, in preschool settings, how much emphasis should be put on domain-specific areas. I think it's a combination. I think within preschool settings, it's important to think around how children learn. So they'll need, you know, in order for them to learn the counting names, for example, and the order of stability, etc., they'll need to be taught the number names, for example, and they need to be taught to link one-to-one counting. So yes, some input around formal activities is important, but also children actually learn a lot within informal activities. And in session 3, I'll go through a lot of what these informal activities could be, and a lot of fun activities that have shown in our research really improve children's mathematical outcomes long term by very simple short games. You know, we always think, and that came out of our research as well, the reason why parents and providers often focus a lot more on reading than on mathematical abilities is not only because of their own confidence levels or knowledge levels, but it's also the fact that mathematical development is often seen as something more formal, something that you have to do at a table with a worksheet and a pen, whereas reading a book can be done after school when 6 o'clock before bedtime in more of a fun and family environment. And I think within a preschool environment, we might want to change that view as well, that mathematical ability or mathematical development should be supported through formal activities. There's actually a lot of informal activities that can develop those skills as well.
We had Shan with her hand up. I don't know if you've still got a question, Shan, or if it's been answered.
Well, I wonder if it might be answered in session 3, but I can ask it anyway. So okay. I was really interested in what you were saying about the connection between gross motor development and kind of children's understanding of where numbers come on a number line and their kind of spatial relationship to each other. And so I was wondering if you could suggest any kind of big activities, you know, where children maybe are using their whole bodies that might help with that. I teach I'm full-time, but 1 day a week when we're out in the woods for the whole day. So I'm always looking for nice math stuff to do out there.
Oh, yes. Yeah, we'll definitely go back to it. But yes, there's a lot of things you can do. So we know, for example, in the woods, you can make a number line with twigs, you know, and put different items, you know, 1 twig, 2 leaves, 3 stones, 4 things, and ask children to develop a physical number line of items and to space those out equally so that they kind of get that concept around, you know, what's a unit, for example, what is 1 and 1 makes 2, and obviously a unit can differ depending on what object you've got or the size of the object or etc. So you can really play with these visio-spatial abilities of the number line and have a long number line and a shorter number line. And obviously in a shorter number line, the numbers are just closer to each other, but are still equally spaced between each other. And that's something that takes a while for children to understand around what the relationships are, or between 1 and 10 and 11, for example. Those are the tricky ones. So with whole body, it's also just, you know, this orientation, knowing that up means going towards the right of the number line, going down, or, you know, subtraction is going to the left of the number line. And is that kind of teaching children those what we might think is simple concepts, but that's really crucial for children to understand subtraction and addition, for example, or then later on multiplication as well.
Oh, that's really nice. Thank you very much.
Thanks,
We've
Jan.
got a question from Colleen. In preschool setting, how much emphasis should be put on domain-specific areas? Don't know if Colleen has anything else.
Yeah, I think I've just done that one where I was saying, like, yes, there should be some focus on it, but it could maybe also be done through informal activities. Because again, I think within informal activities, there's a lot more focus on those domain general abilities, like Sean was asking around, Visio Spatial, through doing it in the forest, for example, through play. That often gives children also the numbers in front of them, the objects, which again helps with working memory ability. So doing it in an informal way often provides the natural context for children to learn. But also, mathematics is something we apply in our daily life, right? So doing it therefore through play allows children to see the relevance and how it can be applied to things. It's a good memory aid as well. I'll never forget that when I was taught around pi being 3.14, we all had to bring round things to school and measure it, and then everybody measured it independently, and then the teacher asked, so what is it? And it was 3.14 and 3.14 and 3.14, and nobody ever forgot that it was 3.14. So I think learning through activities really helps, especially young children.
Perfect. I think we have a question from Vida. Did you want to come in and ask your question? Oh, you're still muted, Vida.
Sorry, I was wondering perhaps if in the primary school we push mental math skills then maybe too early,
I think it depends on which ones, but I think there's a huge push for children to do mental. Now, obviously, if it is, it's good that children can rely on their, acquired learned knowledge, right? So, subitizing and relying on subitizing is good. So teaching children that's 5 and you don't need to count, one hand is 5 is a good skill, because we know subitizing skills scaffolds later on more complex mathematical abilities. But obviously, if we ask children to do mental arithmetic before they really can hold information in mind, so I think there's two different things. Yes, you can train children to recognize things immediately, like timetables, 4 times 4 is 16, so that they kind of retrieve that information from their long-term memory instantly. It's not a bad thing. But obviously, if we want them to count onwards or number bonds and split numbers, if they don't have that mental ability yet to keep track of which bond did I just tell you and which other one do I now have to tell you, then obviously we're going to set them up for failure. So it's kind of trying to understand what can children do without manipulatives and retrieve directly from memory, and where do they still need help with. And working memory abilities develop up until the age of late primary school age. So sometimes I think we do ask children to do too much too quickly. And also in England, within the new early years framework, we see that there's actually a lot of this learned knowledge is now moving to the early years that was previously taught in year 1. So there's kind of, there is this kind of speeding up of the curriculum that is happening.
Yeah, no, that gives you confidence to kind of get back to using the concrete materials and the number lines, and yeah.
Yeah, absolutely. And I don't think, I think it's a little bit of a myth that children will then long term rely on them a lot longer. I think the opposite is more true, is that if we set up children to fail, they'll drop maths more quickly than if we give them manipulatives. That they'll, rely on them for a lot longer, and it will harm their mathematical abilities in the long term. I think that's less likely.
That's brilliant. Thanks very much.
You're welcome.
Thanks, Vida. We're actually almost at the end. Carol, I don't know if that was just a statement that you were wanting to make. I don't know if you want to come in, or you maybe had a kind of question off of the back of your comment. It must have just been a statement. That's absolutely fine. And it was just that
Susan, Thomas had asked a question earlier in the chat around any research or guidance that you could point them towards around developing family learning, around numeracy, spanning ELC into infant stage.
Okay, I need to break that down because there's a number of things in it. So research around...
Is it okay to speak?
Yes, of course.
Fantastic. It's just that we are sort of noticing a trend whenever we're doing assessments, sort of in P1, and we're seeing a sort of. I know COVID's obviously had a big part in it as well, but even before that, we were seeing like lower attainment, even coming into P1, and I think speaking to a few parents who are really well intentioned, but they kind of feel almost, I don't know what I'm doing, I'll leave it to school or I'll leave it to nursery. And it's just like looking at little things. I'm in Highland and we've got a really good educational psychology pack about helping promote attainment through literacy in the ELC, but we don't have anything for numeracy, and it's just to try and help encourage parents to build it into day-to-day life, part of the conversation. And not anything onerous, but just encouraging them to be part of their children's learning.
Oh, thank you so much for asking that. So we've developed an app that is called Maths at Home app, and it's a bank of ideas for parents to use with their children from the age of 18 months up until the age of 5. Unfortunately, where we're at it with the app is that an app development, even though it's a bank of ideas, costs a bit of money to keep it on the App Store. So we need to source some further funding to maintain the app on the source. But it's a great app, very simple for parents to use, and gives you all these ideas around what parents can do in their home environment, why it's important, what to do with your child. They only take 2 minutes. I can definitely send you more information. The other thing to look at is in session 3, the activities I'll be talking about are for actually parents to be using at home with their preschool or younger children. And also I've been working with Save the Children, who've got a home learning environment and home learning pack to improve mathematical abilities for children who are low attaining for mathematical abilities. And I'm sure I can link you up with those materials as well.
That'd be excellent, thank you.
You're welcome. And if you know anyone who wants to co-create our app further, let me know, because we've piloted it. Parents were very keen. It's always the problem around funding.
It's probably not going to be me because I can just about log into Teams. So
no, I understand. It's also it was also a little bit more work than I anticipated originally.
Brilliant. Shan, just one last question.
So I teach primary 2 to 7, and when Flash was discontinued, so many kind of online maths games that were really great now just are not available. So it's kind of just a general, a general thing to say, like, oh, maybe we could have some of these back sometime. Maybe there's someone who wants to build them. Yeah.
I'll definitely look into it. Because I think there is a real demand now for more activities that parents and teachers can do around maths that are backed up by research evidence, basically, but yet easy to implement without huge cost or effort, basically.
The Centre for Game Science had a really good one called Ratio Rumble, and my older primary children just loved it, and they completely nailed ratio from it. But it's gone.
Yeah, I know. Yeah, there are a lot of good of these simple apps that really do teach children the basics that they need for further mathematical ability.
And one thing just to end on, if that's okay, is what we're going to do is we will be sending out the presentation, and we'll send out some links, and there's actually some further reading as well. And we'll also share any resources as well that we can certainly pull together. There is a family learning maths and numeracy working group, which consists of, I think a couple of them are here on the call today, which is Claire Smith from North Ayrshire, Rachel Kerr from Renfrewshire, and Stephen Hendry from the Royal Institute of Chemistry, and we're working on pulling a lot of the resources together in a Wakelet specifically around family learning, so we would ask you to look out for that as well. But Jo, we're going to go over some resources and activities to use at home in the third session. For those of you that are having some difficulties, these sessions were sold out very, very quickly. But as you can appreciate with online sessions, there is a specific drop-off rate. So we will make sure that whoever has asked to be added to the second and third session today is added to them. So don't worry about that. But I'd just like to thank you, Jo, for this session. It was fabulous, really thought-provoking, and the conversations were great. A lot of really interesting information. So I'm going to give you the floor to see if you've got anything that you wanted to end on, and then we'll end the session.
Well, I want to thank you all for your very interesting questions and for listening. And I hope if I've just showed you one thing is around how much mathematical abilities or improving them is more than just improving maths, but also to think around all the other domain general abilities, the home learning, your own knowledge, affinity, anxiety around maths, that is all important.
Can I just say one last thing before everybody goes? So one of Jo's colleagues, Dr. Rebecca Gordon, has been doing some sessions for us on the relationship between working memory and long-term memory. So you will have heard Jo talking about that. So the first session was yesterday, but there's another session next week and then at the end of October. So if you're interested in making those connections between what Jo's been saying and what Rebecca is going to be talking about, do sign up. The links are in the chat pane.
Okay, so thanks very much, everybody. Enjoy the rest of your night, and hopefully we'll see you tomorrow and next week.
Fantastic. Well, thanks very much. See you tomorrow.
Thanks, Jo.
Take care for now. Bye-bye.